Welcome and hello. This is a video exercise in MODSIM, and in this exercise, we are going to be dealing with model-generated lag factors. All right, so these lag factors appear all over the place in MODSIM. So for instance, they're in reservoirs, reaches, and demand nodes. Let's go ahead and get started. I have the interface up right here, and I'm going to sketch out a network model. I'm going to point out a few different places where we're seeing these model-generated lag factors. Then I'm going to do one demo, both manually creating lag factors and then allowing MODSIM to automatically generate those lag factors. Okay, so let's get started. I'm going to click on reservoir and then add a reservoir. I'm also going to add some non-storage nodes. How about there? And then a sink at the end and a consumptive demand right there. Okay, I'm going to go ahead and zoom in and then call the reservoir res1. This will be N1, non-storage node 1, N2. This one here will be N3. The demand, I'll just call that D1, and then I'll leave the sink labeled as it is. All right, let me go ahead and now connect some of these nodes together and also move the labels. So let's see, node 2 to node 3. Node 3 will serve demand 1, and then demand 1 to the sink. Okay, so that's pretty straightforward. Now to control whether or not your model is using user-generated or model-generated lag factors, you're going to want to go up to this MODSIM menu, click on Network Settings, and then right here under Lag Factors, here's the option. User-generated is what it currently is set at, but model-generated is also an option. If you select model-generated, you can also specify the number of lag factors right there. So I'm going to be returning to this dialog box to switch this back and forth just to show you what some of the other dialogues and user interfaces within MODSIM look like based on the selection for the lag factor type. So for now, I'm just going to leave it at user generated. Click apply. I'll click OK. Let's go ahead and take a look at this demand node first. So if I right click and then open up the properties, here are the properties. It's set to consumptive. And when it's set to consumptive, we have that groundwater tab right here. There's some pumping options and some groundwater infiltration options. I'm not going to go into too many details about this. I'm sure I'll do another exercise on this exact topic. But what I do want to point out is when you create pumping or groundwater infiltration, you want to create a table. And in that table, we're going to identify a depletion location, select one of our non-storage nodes, and then down below here, we're going to manually enter the lag factors. These lag time steps refer to the time steps of the simulation. So if your simulation is 1 month for the time step, then lag 0 would be the same time step. Lag 1 would be the following time step, which is the next month. But you could also have, a daily time step, a weekly time step, some user generated time step value. So there's that. There's also a similar interface when you click on this create table for the infiltration lag data. So as before, you're going to specify the return location. That's a non-storage node because it's going to be accepting water just like by manually specifying an inflow to one of these non-storage nodes. Okay, so you'll be defining the lag factors manually that way as well. Okay, I'm just going to click cancel out of here. And notice that the top part of this groundwater tab just starts with the groundwater pumping, with the pumping rate, pumping priority, and so on. We're not actually expected to type in any aquifer data or any soil data. But if I switch the lag type to model generated and then come back to this interface, you'll see that those parameters are now available for us to input. So let's do that. I'm going to just cancel out of this, come back to our MODSIM network settings. And then for the lag factor type, I'll select model generated, apply. Okay, let's come back here to our demand node, open up the properties window, and then select the groundwater tab. And as I mentioned, now we have some stream aquifer model parameters that it's asking for, where the specific yield, transmissivity, and average distance to return nodes are initialized at all zeros, but what we want to do is input that data. And we no longer have the option to create a table like we did previously, because that was how the user generated the lag factors. Now the lag factors are automatically calculated based on these aquifer values. Okay, that's where the model generates its own lag factors with regard to groundwater pumping and infiltration at the demand node. Another couple locations are in the links. So I'm going to pick on this link up here, N1 to N2. I'm going to go right click, open up the properties box. The different link types here are default, channel loss, and channel routing. So for both channel loss and channel routing, this is another opportunity for the lag factors to be either user defined or generated based on the model. Let's go ahead and switch that back to user defined first. So here is user defined, apply, okay. Now back to our link properties dialog box. Let's go ahead and select channel loss first. So we have a channel loss tab that shows up. And then down here, we have the lag factors that we're going to input, as well as the loss coefficients. Now, keep in mind this grayed out section is the aquifer properties, which will become enabled in just a moment once we switch it back to model generated lag factors. But for now, this section is enabled and it's expecting us to type in lag factors. All right, so if it isn't the channel loss type of link, we can switch this to channel routing. And then if we select the channel routing tab, now again, we have lag factors here, which we type in instead of not aquifer properties, but the Muskingum parameter values for X, K, and subreach count. So keep that in mind. Let's go ahead and switch that back now. So I'm going to close this dialog box, go up to the MODSIM menu, click on Network Settings, and then for the lag factor type, I'll select that model generated, click Apply, click OK. Now let's right click, open up the properties to that link once again. We'll select, how about channel loss? I'll click on the channel loss tab. Now here's the section, it says model generated lag factors, but instead of us manually typing them in, it's expecting us to type in those same aquifer properties as before: specific yield, transmissivity, and then the average distance between the link itself and the specified return node right here. Okay, so we will get to an example of using these in just a moment. Let's talk about the reach routing now. So if I go back to general, and then instead of channel loss, I click on channel routing. I have this channel routing tab, and we click on that. Boom. Now we actually type in the Muskingum X value, the Muskingum K value, and then the subreach count is fixed at 1, so that's not something the user can change here. And then further down below, what used to be a user input form for us to type in the percent of lag for each time period, that's all grayed out. There's nothing to do here. So those lag factors get calculated automatically internally in MODSIM during the simulation, and it all takes care of itself. All right, the final example of the user generated versus model generated lag factors is in the reservoir. And I'm going to talk about reservoir seepage. So to do so, I'm going to, let's first of all change this back to user generated, apply, and OK. And I'm also going to actually populate the model with some data so we can run the model as well. So to do that, I'm going to right click, open the properties box for this reservoir. I'm going to click on the general tab. Now let's set it to a maximum volume of 100,000 acre feet, and then we'll initialize that volume to 100,000 acre feet. There's not going to be any inflow into this reservoir, but we are going to lose water from this reservoir in the form of seepage. In fact, I'm going to click apply and OK. And just to demonstrate that seepage loss, I'm going to actually remove this link so we know for sure that flow into node N3 is from seepage and not from the actual link flow or reservoir release into node 3. All right, so let's go back to our reservoir properties here. The next tab I want to click on here is groundwater seepage, and I need to define a seepage rate. So I'll just type in something like 0.05, which means for each time period, the reservoir is going to release or lose 5% of its average storage during that time period to seepage. So I think this is an overestimation, but I wanted to just make it a little bit larger than normal so we can see some larger numbers in the seepage values. All right, further down here, if we're doing user-generated return lags, we have this option to create a table. So we're going to do the user-generated first and then compare it to the model-generated, but I wanted to just kind of demonstrate that difference. So for user-generated, I'll click on Create Table. What I need to fill out in this dialog box is the return location. So this is the location that the seepage flows to. I'll select node N3, so any of the non-storage nodes. For fraction return, I'll just leave that at 1. And then down here is where the user specifies those lag factors. So I'll say 0.35 and 0.15. These lag factors need to add up to 1. If they don't, say I add another zero point 0.5 at the end, 0.155, I click OK. I get this error message. It tells me I'm 5 thousandths over, so I'll retry and then make it right. Click OK, and boom, there is my record. I can add additional tables as well, but let's just go ahead and stick with this. So I'll click Apply and then OK. I don't think we're going to get that much seepage, but we'll see what happens. So let's go ahead and click. Oh, I need to save first. All right, so here's the project directory. I'll just call this, yeah, network fun is fine. Save. So that ran. Let's go ahead and check out the flow through N3D1 link. Okay, so here we have it. This is the flow rate on a per month basis. It looks like we start at 2450 for the flow rate, and then it goes down to about 1400. The reason why it's decreasing is because the amount of seepage is a function of the volume of water in the reservoir. And this right here leads me to believe that the reservoir is dropped down about 60% of its total capacity over that year, just by looking at this plot right here. We can just confirm that or deny it based on right-clicking and click on graph. This is the reservoir release. Now we need to change the units here to volume, and boom, yeah, it looks like we dropped down to about 55% the original capacity, or the original storage was up here at 100,000. And then due to that over exaggeration of seepage and the user defined lag factors, boom, we now have only a volume of about 55,000 acre feet at the end of that calendar year. Okay, so that was user generated lag factors. Let's go ahead and switch it up now. So the MODSIM menu, network settings, I'm going to change this to model generated and then click apply, click OK. Let's go back to our reservoir properties window. And then I want to click on the groundwater seepage tab again. We're going to stick with the same seepage rate. And then down here, we need to provide the specific yield, transmissivity, and then average distance to return nodes. All right, so what I have in my notes is a table here that shows typical or a range of specific yield values and transmissivity values for different types of soil. So of course, we're going to have larger transmissivity for more porous soils, and same with specific yield. This is assuming a unconfined aquifer. So if it was confined, we'd have specific storage, not specific yield. All right, so let's go ahead and just throw in some numbers. If we had a sandy aquifer, then I'm going to maybe say, yeah, somewhere between mild fine sand and coarse sand, like a medium sand. I'll say maybe 0.12 for the specific yield. And then for the transmissivity, I will type in maybe 5,000. So that's middle of the fine sand range. Oh, but also qualifies as coarse sand. Okay. So let's do those numbers. Specific yield 0.12, and then transmissivity is 5,000. That's in units of feet squared per day. Now I'm not seeing the units right here, so I'm just going to assume it's feet squared per day. Specific yield is dimensionless. And then the average distance to return nodes. This also does not say what the units are, but I remember seeing in another dialog box that it said feet. I think that was the groundwater pumping one. I'm just going to type in a number. We'll just keep it small and say 100. If we make this number larger, it may not actually have any seepage to that node, but we can test that out too. All right, down below here, we have a table that says what fraction of that total seepage amount goes to which node. So remember, we have 3 non-storage nodes. So I could go down here and specify a different one, and then those fractions would have to sum up to 1. I'm not going to do that though, so just escape. I'm just going to say all 100% of the seepage flows here to N3. And then as for the user-generated lag factors, that's grayed out here because we told MODSIM we want the model to generate those lag numbers. Okay, I'm going to click Apply and then click OK. I'm going to save my MODSIM network and then run. Okay, so it said that ran. Let's go ahead and check out our flow between N3 and D1 plot. Okay, so I'm looking at the volume right now. I need to switch the units over to flow. Boom, here's our flow. Looks like some similar numbers, 4,600 down to 2,700. Our units here are in acre foot per month. Let's go ahead and modify some of the aquifer parameters now and try to perhaps reduce the seepage. So back to our reservoir properties editor, the groundwater seepage tab. Instead of specific yield of 0.12, I'll say it's 0.08. And then instead of transmissivity of 5,000, I'll say it's maybe 800. And then an average distance, I'll make it 500. I'm not a groundwater expert. This is assuming 1D flow. By the way, this isn't mod flow with 2 dimensions and or 3 dimensions. It's a rather simplified groundwater equations that we're working with here. So I'll click apply and then click OK. And then let's run the model once again. Yep, I want to save it. Okay, so it looks like that ran. Let's go ahead and take a look at the graph now and then switch units back over to flow. Okay, definitely some smaller numbers. So instead of, what was it, 45 or 4,700 acre foot per month for the first month, now it starts off at 2,500 acre foot per month and goes down to about 1,500. And because we have less flow here in this link, N3, remember, is a non-storage node. We can't have storage. So basically, due to those different aquifer properties, we have less seepage reaching node N3 and hence less flow downstream from node 3 to demand node D1. All right, well, that's it for this exercise. What we talked about was user-defined lag factors. We compared it with manually defining those lag factors in MODSIM for demand nodes for groundwater pumping and infiltration within the links for channel loss and reach routing. And then finally, we did the demo for the reservoir regarding groundwater seepage.